Let's take it up a notch and combine the two things that we've talked about here in part 3. The first one, we're going to actually be dealing with lead for these two problems. For the first problem, it basically says a sample of lead contains, so it's not the question at first, but it's what the information that's given. So we're going to start with these number of Pb atoms, lead atoms, and it wants to know what is the mass. So question mark grams. Well, the way we're going to work this, and I'll be talking about in the next few slides, is do you see where we can go from atoms to moles? What do we use to do that? We use Avogadro's number. The fact that 1 mole is equal to 6.022 times 10 to the 23rd atoms. Okay, so that will give you from atoms to moles. And then how do we go from moles to grams? I'm just going to simply put MM stands for what? The molar mass of lead. Very good. That's kind of the strategy. The second one, a sample of lead has a mass of 0.330 grams of Pb, and it asks what is the total number of atoms. So question mark atoms. Well, can we go from grams to moles of lead? Yep. We'll do that using what? The molar mass of Pb. And then can we go from moles to atoms? Yep. Using what? Using Avogadro's number. Avogadro's number. This right here. Okay? That will get us from moles to atoms. So, probably a little more organized. Okay, I'm at my next slides here. Again, we're going to use Avogadro's number when we need to go from atoms to moles or moles to atoms. And these are from that equivalency statement. These are the two ratios that we can use. Remember that we would use this one if we want atoms to cancel, and we would use this one if we want moles to cancel, right? Okay. So we also need to use the molar mass of lead. From the periodic table, and I'm not sure why this is, but the molar mass of lead, it only gives it to the nearest tenth of a gram per mole. So it's 207.2 grams per mole. Again, working problems, I should never see the 207.2 G/MOL. I should never see that in a problem. I should see it unpacked like this or flipped like this. Again, we're going to use this one if we want moles to cancel, be left with grams. We're going to use this one if we want grams to cancel, be left with moles. We could also flatten it out and it looks like this. That's a physical property of the element lead. Okay, so working the first one, again, the first one we were given a certain number of lead atoms packed up in scientific notation, and we were supposed to go to mass from number of atoms. We can't go there directly, but we can go through moles. So remember, this is going to be our first step. We're going to go from number of atoms to moles of lead using Avogadro's number. 1 mole of atoms is equal to 6.022 times 10 to the 23rd atoms. Once we have moles of atoms, we can go to grams of material by using the molar mass of lead. And we said the decimal number for lead is 207.2, and that would be grams per mole. All right, what's the first term going to be? It's going to be that 7.87 times 10 to the 23rd atoms. And a lot of times if I'm only dealing with one element like I am here, lead, I won't even put lead there. I'll just say atoms because it's all lead atoms. Put that over 1. Now what does the next term look like? I want atoms to cancel, I'll be left with moles. So it looks like this. 1 mole over 6.022 times 10 to the 23rd atoms. Atoms will cancel, be left with moles. Now we are, if you're kind of keeping track with our game plan up here, ready to go ahead and use this. I want moles to cancel, be left with grams. So what does that look like? that looks like this. I want moles to cancel and be left with grams. So I use it that way. Hope that works for you. So now our units work. We have actually what we were after, grams. Let's see, is there any uncertainty brought by this first term? Yes, there's only 3 sig figs there. Is there any uncertainty brought here? Yes, 4 sig figs. Any uncertainty brought here? Yes, I'm getting 4 sig figs again. So we need to round according to how many sig figs? Looks like 3. So I got, see if you got this too. I got 271 grams of lead. So if we were going to kind of define what this problem was, this was a going from atoms to grams problem, if you're into kind of classifying problems. Let's take a look at number 2. So number 2, we start with grams and are going all the way to counted number of lead atoms. So we can go from grams to moles using the molar mass of lead again. And how are we going to go from moles to atoms? We're going to use Avogadro's number. Very good. All right, so what's our first term going to be? It's going to be that 330, it's going to be that 0.330 grams of lead. And I would usually put that over 1. Okay, so now our first step is to go from grams to moles using the molar mass. So what does that look like? We want grams to cancel, so they'll go in the bottom. So we have 207.2 grams in the bottom, 1 mole in the top. Looking good. So now we're ready for this step right here. So now we want moles to cancel, and we want to be left with atoms. So what does that look like? 6.022 times 10 to the 23rd atoms on the top, 1 mole on the bottom. So our moles have canceled. And again, it's all about, you have confidence in your problem if you have the right units left. So we have the right units left. It's perfect. So is there any uncertainty brought by this term? Yes. How many sig figs? I'm liking 3. Any uncertainty brought here? Yes. Sig figs? 4. Uncertainty is brought here. 4 sig figs. So how do we need to round this? I got 3 sig figs to round this. So it's going to be a big number, right? Because we're counting atoms. So we show 3 sig figs here in the coefficient. So I got 9.59 times 10 to the 20th lead atoms. Here's a question for you. If you have this number of lead atoms, is this greater than a mole or is this less than a mole? Right, it's less than a mole because a mole is 6.022 times 10 to the 23rd, okay? And this is times 10 to the 20th, so it is actually less than a mole. Alrighty then. So we're bumping up against an assignment slide. In this assignment slide, I did go ahead and emphasize a few things. So you need to show all of your work, okay? You need to use the factor label method like I've been showing in lecture. And you need to round according to the correct number of sig figs. Good luck.